Well, one of the ways that we can use to evaluate or organize the truth values of statements is to set up a truth table. And we've looked at truth tables when it comes to uh, negation and conjunctions and disjunctions. And we can also use it when we're evaluating or organizing for a compound statement. And so here we're asked in example 3 on page 101 to construct a truth table for the negation of P and the negation of Q. Statements P and Q, the negations of both, and we've got a compound statement here that this is an and. And so for an and statement to be true, both statements have to be true. But let's first go over here and let's begin to set up our truth table. Now, our basic format in our first statement, in this case it's P, we would have true, true, false, false. And then for our second statement, Q, our basic format, the one we would have in the second column, is going to be alternating true and false. True, false, true, false. All right, now that we've got that done, the basics set up, then we're going to look at the negation. So here we have not P, the negation of P. Well, the opposite of true in this first row or in this row would be false. And also, as this is true, well, the opposite of that is false. And we got two false statements at the end, and so both of those we would set as true. In other words, if P is false, well, the negation of that, the opposite of that, is a true statement. And now we're going to do the same thing for the negation Q, and this time rather than be alternating true, false, they are false, true, false, true. And now finally we can use this truth table to evaluate this compound statement, not P and not Q. Now remember, for both statements, for it to be true, they both have to be true. So here we've got negation of P, not P, and not Q. Well, they're both false, so obviously this statement is false. And secondly, we got where not P is false and not Q is true. Well, they're both not true, so the compound statement, not P and not Q, is also going to be false. And let's see, this third statement, not P is true and not Q is false. Well, the compound statement of that, not P and not Q, they're both not true, so it is false. And then lastly, we got not P and not Q. Well, not P and not Q in a compound statement. Now both of those are true, and so this last statement is, in fact, true. So there's just a basic setup of a truth table. In this case, we were looking at the negation of P and the negation of Q. And there we go. Again, key thing here, this first column is going to be true, true, false, false. Second column is going to be alternating true and false, true and false. And then we just apply the negation, the opposite of, so this is the opposite of what we see in column P. This is the opposite of what we see in column Q as it relates to true and false. And then we evaluate the compound statement where for the compound statement to be true, both statements have to be true. And in this case, we find that the last one gives us a true statement.